All right, so the first homework question was, how many moles of iron are there in 7.25 times 10 to the 28th atoms of iron? Okay? This is just like the work we did in class yesterday, but it's not exactly the same problem. Yes? You want to do it? Okay, well, do you want to come up here and do it and get help through by coming over and doing it? Sure. That's a great way to do it. In fact, you'll probably get more help that way than any other way you could possibly do it. Absolutely, you can do the second one.
Can you explain to me how to do it?
Well, that's what everybody's going to do. Everybody's going to help you. Okay?
Yeah,
Is that trash? We're going to put it in the recycling bin. Okay? All right, so do it where, whoa, don't, now if you want to turn it, that's fine. Put it where you want it. You put it where you want it, and I'll turn the camera. Oh, you can't what? All right, go ahead. All right, now the whole class now is going to work with her to get this done.
I'm scared.
So what's the first thing you do?
Okay, you gotta do equality or equality.
Gotta write an equality statement. Okay, so we're converting from, show the problem on the screen there. We're converting from atoms to moles. What is the equality statement for converting from atoms to moles?
You're gonna do
Equals one mole equals 6.022 times 10 to the 23rd.
Of what?
Anything.
Well, yeah, but, all right. So, the way you state that is this, and listen carefully because I said it yesterday about 3 times. I want to make sure it's really clear. You're right up to a point.
Yep.
6.022 times 10 to the 23rd of anything, which means any kind of particle you can think of, okay, is equal to 1 mole of that thing. What is the thing here?
10 to the 23rd?
Yeah. 6.022 times 10 to the 23rd. We watched the video, by the way. I sent you a link to that yesterday.
My phone's broke.
I'm sorry. Go to a computer and do it. All right. So 6.022 times 10 to the 23rd of anything. What's the thing here in this problem?
iron.
Well, yeah, iron is the thing.
7.20.
Well, the 6.022 times 10 to the 23rd of anything. What's the any here? That's the iron. Okay, I'm sorry. Atoms is the any. The thing is the iron. Okay? Atoms is the any. Thing is the iron. So moles of that thing would be moles of iron. So write that down right here. 6.022 times 10 to the 23rd of anything.
So you want me to do 6.22 times 10 to the 23rd?
6.022.
Oh. Is that what I've been getting wrong?
No, 6.022. That's Avogadro's number. Huh? That's his number.
Do I do that?
Yes. Atoms. That's the any. Atoms is the any. The thing is iron.
Atoms.
Iron.
Iron.
Fe is a symbol for iron. Okay, good.
Okay.
Equals.
The 7 point...
No.
No,
1.
1. Oh.
1 mole.
Oh. 1 mole
Of that thing.
of Fe.
Of Fe. That's right. The thing is iron. Okay?
Okay.
Now, that's how you write your equality statement. And from the equality statement, you can build a conversion unit. And conversion units is how we're going to get from, let's see what we're doing. We're getting from atoms to moles. Okay? So, what's the first thing we're going to do to write the actual problem now?
Conversion.
Not that's the first thing. The first thing we have to do is something else. We did it yesterday 3 times in class. We did it in Unit 1 over and over again. What?
Put it over 1.
Put the starting amounts over 1. We did that over and over in Unit 1. We did it 3 times yesterday.
I just put Fe for atoms? So hard. Okay, and then times 6.022 over 1?
That's on the bottom.
All right. So do your crossbar there for your fraction.
Crossbar.
The line, okay. So what's going to be put on the bottom now?
The 6.822.
Why?
Because E equals 1 mole of Fe.
Well, what goes on the bottom is atoms of Fe because atoms is that's no. Because you have atoms of Fe on the top, you want atoms of Fe on the bottom.
Okay.
And to get atoms of Fe on the bottom, you have to put that number with it.
What did you call them, Mr. Tedder?
What? The species is the chemical. Iron is the species. Units of measurement, well, there aren't really any units because atoms are particles you count. Okay, but we can call that a unit. Okay?
Okay, so I'm doing this right now.
Yes, you are.
Okay.
And the other side of the equality statement goes on the top. Y'all remember that? Unit 1? Yeah. How many of you actually did what I asked you to do yesterday, and that was to go back and look at Unit 1 notes last night? You hurt me.
And
You
then
hurt
do I
me.
cancel out the atoms Fe?
Well, you got to put moles of Fe up top first, because that's up there. Okay, it's in the equality statement. It's got to be there.
Right.
Okay. Now you can cancel. Atoms can cancel. Fe can cancel.
And then I just divide
And the question's asking you for moles, and this is going to get us to moles because that's what's left. You got to have a calculator, right? You want my calculator or do you want to use your calculator? You really ought to practice your calculator, but that's up to you. Do you have your calculator today? Because the more you practice with your calculator, the more you're going to understand your calculator's language, syntax, okay? The more effective you are at solving these problems on the test. Okay? Right, Carlos? Right, Zach?
Hey, guys.
Sit up, Zach.
Woo! Probably did not
You
do
put
this
your
right.
2 parts in parentheses?
Yes.
Okay, good.
Yeah, put what in front?
Okay. That's right, you weren't here yesterday. So, this problem, this number right here is actually 2 math problems. I've got this math problem, 10 to the 23rd, and I've got that times this as a second math problem. I've got 2 math problems down here. Well, your calculator doesn't know how to mix and match those unless you tell it how. And you tell it how by putting all of this in parentheses, then divided by all of this in parentheses. Okay? And then you should get the correct number. That's not bad. Okay? But now you probably ought to move your decimal place. So let me show you something on this calculator right here. You still need to get another battery, don't you?
Yeah.
Okay. See where it says Science and Engineering?
Yeah.
Let's press second and that button and move this over to Science and hit Enter, and there's your number in scientific notation.
It just gave me the same.
That's cool.
Okay? So it's 1.20 in all these numbers
Right.
times 10 to the 5th power.
Yeah.
That's the way it looks on this calculator. So that sort of superscript 05 means times 10 to the 5th. Got that? So, and it says down here times 10 to the 5th, little bitty letters right there. So if you'll write that answer out, the complete answer. Yep. I will. That's good. Oh, wait a minute. Yours is rounding off. You need to have it give you all the numbers. I know that has to do with the setup somewhere.
I know. I read my
If
boys here.
you want to come in, I'll help you try to get the mode, the setup fixed up, so you can get all the numbers. I want you to show me all the digits and not have it automatically round off to 2 digits. Okay, we get to some of these numbers don't work for you. Okay, all right. What has she not written down, guys? Don't help her out.
The
What's she not done
units.
here? Oh, now don't give her a hard time. Just help her out. She had the guts to come up here.
Yeah.
That's right. What'd she do next?
Do I round it?
Come on, Carlos.
Yeah.
Get in the game.
Let's go, baby.
What's she gonna do next?
Do I underline from the 0?
After the 0, yes, because you've got 3 digits in that first number, and you want to have 3 digits in your final answer.
How do you know where to round?
Look at the numbers in your problem. Find the number with the least digits. In multiplication and division, that's the rule. Okay, but it only applies to multiplication and division. Doesn't apply to addition and subtraction. Okay? Very good. Now, the last thing I'd like you to do, it's not really required, I won't count off if you don't do it, but it'd be nice if you put it in a box so that if when I see the answer, I know which one I'm looking for, and I don't confuse it with something else and end up counting it all wrong because I can't find your answer because it's a mess. Okay? And you write really neatly, okay? But some people, some people. All right. Nicely done. Y'all, she should do this all the time. She writes better than I do. All right. Here we go. Next victim.
Can I move this paper out of the way? You talk about the problem, Connor?
Just if you want that, we see the problem. You can show the problem to everybody if you want to, but then you want to just construct the answer, basically. Okay?
I have to do an equality statement, don't we?
If you're going to convert, you have to have an equality statement.
Okay.
If you're going to convert, you have to write an equality statement.
I got a question.
What? Y'all gonna help her out? Or y'all just gonna sit there like knots in a line? Come on now. Help her out with the equality statement. What you got to do?
Same thing that happened in number 1.
Okay. What's the only difference? It's molecules. The molecules are particles. That's in anything.
Yep.
Put 6.022 times 10 to the 23rd molecules of CO2
You know I had the other day with better? That was
What?
amazing.
equals 1 mole of CO2.
Equals what?
1 mole of CO2.
Okay. So 6.022 times 10 to the 23rd of anything. Anything. Any molecules, thing, CO2 is equal to 1 mole of that thing. There it is, that thing. Okay? Got it? All right. So what's the next step then?
Put
Come on, Brianna, help her out,
Yeah, put
man.
it in fraction.
Eli, get in the game.
Put it in fraction things.
3.35.
Now, where did you get that from?
The
The problem says that's the
starting.
starting amount. Right, you got to put the starting amount over 1 every time. Huh? Okay. Then build a conversion unit. Let's see if she can do it for herself now. Where does the 1 mole go? On the top or the bottom?
Right.
The bottom. On this one, it's the bottom.
On this one, the mole has to go on the bottom because you got moles on the top in the first part. Oh.
White out,
So,
Hannah.
this, okay.
You see?
Yeah.
Because you're not going to be able to cancel 1 mole that's on the top. We'll have moles squared on the top here. We don't want to do that. Hold on a second. Don't write with my felt tip marker through that stuff. I'll give you a pencil to write through that if I can find a pencil.
I got one.
I know, I've got one too. I got bunches of pencils, but I've got to find one. Put my hand on it. Okay. It's probably not dry yet.
No.
Go ahead and write through it. What goes on the top?
1.
Oh, ho, wait a minute. Hold it.
Whoa.
Is there somebody not called her on this
How
yet?
did you
My
get
bad,
23?
you did it wrong. That has to be on top.
Now look, 1 mole, the mole right here is 1 mole, and you put 6.02 10 to the 23rd. Oh no! But you know what? Look, better to find what your misunderstandings are now, right, than on the test. Okay? So, Hannah deserves to be applauded because she's got the guts to come up here and see where their errors are. In front of everybody. God and everybody. No.
He's preaching.
Oh.
Am I doing it right now?
Yeah.
Now you got it. Now you're on track. You see why?
Yeah.
Okay, good. And you don't need the word of, but that's okay. You can leave it there. And 1 mole. There you go. Good. Cancel out. Cancel out. There you go. See, you got molecules left, and that's what you're trying to find.
Oh, I forgot my calculator.
Oh, here. Just use this one if you want to. If you know how to use this one.
My calculator doesn't work for that.
Yeah.
Well, you got to hold it. Let's use your calculator because we want to make sure you know how to use your calculator. Okay? You got one that's very similar to Prima's. Wait a minute, you're not going to put it on the screen so everybody can see?
Oh, well.
I will when I get done.
We want to see what buttons you push, though. We can't help you get the right answer if you don't see what buttons you push.
Show me the wrong button. I don't see no buttons. Come on. I'll see if there's anything.
Well, I do not hit.
No, I'm looking better anyway. So now I can't. You just move it out of the light. No.
We'll move the light around. Don't worry about it. We'll get there. Oh, man. That is really good.
Boy.
That is really good.
Yeah, boy.
All right.
Where'd you get that calculator?
Don't worry.
I don't know.
Yes, okay.
How much was it? When is the test for doing this week?
Tomorrow.
Huh? Nuh-uh.
Yeah.
Oh my goodness.
Oh, wait.
I don't know what the test is.
You just started this week.
Huh?
Was that the nursing
But you would round it, wouldn't you?
No, that was
You
not the
would round
nurse.
it.
What?
You'd round that to 2, wouldn't you?
Let's see. We got 3 digits here, 4 here, so we want our final answer in 3 digits.
So 1, 2, 3.
Yep, 1, 2, 3. There you go.
Oh, yeah.
Oh, but you didn't put your units of measurement on that number yet. You have units of measurement and species on both numbers, the unrounded and rounded answer, okay? All right. I know this all seems kind of picky, but trust me, all this is going to help you a lot in the long run, okay? Been teaching this long enough to know where the mistakes, well, not every single mistake, because I'm sure Josh is going to come up with one I hadn't seen before. Okay. All right, good job, good job, nicely done. All right, huh?
Why are you talking?
All right, anybody want to do the third one?
No.
I do.
You want to do the third one? You know how to do the third one? No, because we didn't teach you one here
I want
yesterday.
to do it.
Help? Yeah.
Yeah,
I got
didn't that help them?
right there.
I'll help you.
Didn't that help?
Use for example.
We don't have to write
I'm
a
just-
quality statement for this one.
There is no equality statement for this one. But, what'd you say? You got to have a balanced equation.
Yep. Didn't want to do this one.
This one requires a molar ratio. And a molar ratio has to come from a balanced chemical equation. And balanced chemical equations have to be balanced because,
Need to be balanced. We got to.
what did he say yesterday?
Who said something?
Equations have to be balanced because unbalanced equations are no good. Weren't y'all listening? Y'all
Mr.
took
Ted,
notes on it?
I don't write as neat as
They're
they
kinda
do,
do.
but...
Oh, well, that's okay. You don't have to write as neat as they do.
Oh, man.
What? Unbalanced equations, well, we shouldn't say they're no good, because they do have a purpose. But we need balanced equations for this to work, okay? If you
Is
can't
it-
balance the equation, you're not going to get the right
Is
answer.
it C2H6?
What's that? Oh, yeah, if you want to write it that way, sure.
What other way I was supposed to write?
CH3, you can write it a lot of different ways. Remember how we did all that?
Just write it C6H.
C2H6. That, no, this is ethane. Ethane is C2H6.
I thought you said.
Oh, okay.
No, but you could write CH3, CH3. That in a condensed structural formula. She's writing the molecular formula. Okay?
May I use the rest of them?
Yes, you may. And when you have a hydrocarbon and oxygen, you always get the same products.
CO2.
CO2 and water, and they're both gases. Good job. Why don't you do that on the test? You did. Well, maybe some of you did. Some of you might have. What?
Cameron style.
I don't want to hear who has ISS. No, I'm sorry. I'm sorry I asked.
And why did I give you the things you don't want to know? Yeah, they send you.
Don't. I should take that off the screen.
I'm gonna show everybody though.
Well, they send that to me so that I can try my best to send work to ISS for students to go down there.
Do you? Rick, you need the paper to balance this?
Yes, because I don't remember what I put.
Don't cop no food.
Well, we're going to save oxygen for last. Remember, when you're balancing equations, if you have oxygen, you always balance that last. Hydrogen we balance next to last, so we have to start with carbon. So we get a
Okay.
coefficient 2 by the CO2. And then we're going to recount the carbons and oxygens.
Okay.
Huh?
2,
We'll get a chance to do it, make up.
4, 5.
Yeah, I'm gonna need a pretty good little makeup.
I mean, don't, you know.
There's
Some
not
people,
enough of this.
I did
Okay.
get it on it because I'm good. Can you stand here?
Oh, yeah.
Yeah.
all right, so carbon's balanced,
Okay.
oxygen is last, hydrogen next to last, balance the hydrogen now. There you go.
There you go.
No, what are you erasing for?
What are you
You're
erasing
right.
it for, son?
This? No, I was erasing that.
You don't erase the 5. The 5 was correct.
Oh.
But now you got to rebalance the 5 to mark it out. There you
Okay.
go. There you go.
4, 3, that's 7.
7. All right.
Okay.
1 down.
But you can't do that. So
You gotta
this.
multiply all the coefficients by 2.
There you go.
So this.
There you go. When you get to a point where you got an even number of oxygens on the left and an uneven number on the right, and we got the reason you have an even number is because you got O2. It can't be anything but even on the left.
Mhm.
You've got to multiply all the coefficients by 2,
Except that.
except the one for by 2.
Okay.
Exactly.
So now I have to change this number.
Wow. You have to do a 4.
You don't have to erase it, just draw a line to it. Oh, that's all right. You can do whatever you want to, but
Okay.
I like to draw a line to it so I can see what your error, if you make an error, what it is.
Okay. So 4.
That's 6.
What?
That's 3 is 6.
3 becomes a 6 because you multiply it by 2. There you go. Good job. Good job. Recount everything.
Change everything.
4, 4, 12, 8.
14.
There we are. Now hold it. That's just the starting point, right? Okay. All right. Go. I'm sorry.
Okay, now this is the part I need help on.
This is the part she needs help on. So y'all got to help her, okay? The
Here,
question
Josh.
is, now that we got that, the question is, all right, if 12.25 moles of ethane are reacted with more than enough oxygen, how many moles of carbon dioxide will be produced? You know what a QR code is?
I didn't
Sitting
get
on, I'll tell you
Man.
Okay.
what. QR code.
What's that?
Just wait, I'll tell you, okay? Just hold on. Hold your horse. All right. So, what does she start with here?
This 12.
There you go. It's the starting amount. Put that over 1.
How come you don't get equality state?
Because this is converting from one species to another. We don't use conversion units for this. We use molar ratios for this.
Molar ratio.
Molar ratio. So now we've got to have a molar ratio. The molar ratio comes from the balanced chemical equation. Okay? So we know that C2H6 has to be on the bottom, don't we?
Yeah.
So do that. Put C2H6 on the bottom over to the right. Space and space. C2H6. We know that has to be on the bottom because we've got to both cancel that, right?
Yeah.
And what do we want on the top?
1
Mole.
mole.
Well, what's
No.
the species we want on the top here? We're trying to get to
Carbon
what?
dioxide.
Carbon dioxide. Put CO2 on the top. So we know that, right? Here's the one thing you got to know, and this is from Unit 10, which we took out of order in order to do the ice cream lab. Okay? While it was still warm. All right? The numbers, the coefficient numbers in the balanced chemical equation can stand for individual formula units or moles. The coefficients in the balanced chemical equation can stand for individual formula units, or it can also stand for moles. So if I have 2 C2H6s, we can also say that's 2 moles C2H6.
No way.
Yes, way.
So I put 2 moles.
Yes, right.
How many moles? Why couldn't you just put a 2 in front of it?
Well,
Huh?
we want to make sure we're clear about what we're talking about.
What did you
Okay?
say?
Huh?
What did you say?
He was asking why don't we just put 2 C2H6.
Oh.
It actually works here, but it doesn't always work, so we don't do it. I want you to do it in a way that will always work, okay? So what goes on top? What goes on top?
4.
1 mole.
4.
4.
Yeah, we got 4 moles of CO2, don't we? Okay?
So you gotta use the balanced equation to do this?
But you got to have a balanced equation first. It won't work out unless you do. All right, so how many moles? Got to do the math now. How many moles are we going to get?
I'm not.
Well, where'd you calculate? You got your calculator?
Steve, how do you forget the
It's
calculator?
in
You got
the-
one big knife for me.
No, that looks small.
I'll do it for you. Teacher's letting me down.
Teacher's letting you down. You're supposed to be doing it with her own calculator so she can practice with a calculator. So she can learn its language. Huh? Oh, teacher. Oh, I thought you said teacher. See, my hearing is getting bad.
Okay,
I'm
so
sorry.
I have to cancel these.
I need to get some Q-tips.
Okay, so what do I do first?
Oh, food!
Huh?
Nothing, just do the work.
What do I do first?
Well, how do you do the math? You don't know how to do the math?
Should I do this?
Cross multiply.
You said multiply
Well,
by
it's
4
not cross
first?
multiply. We don't do that in here.
Okay.
Cross multiply is when things are on opposite sides of an equal sign. In this case, you take the 12.25, multiply by the 4, hit equals, then divide by the 2. Yep.
How do you fix the ear infection?
How do you fix an ear infection? You don't fix an ear infection. You help it. You help your body to heal an ear infection. Depends on the kind of ear infection. But I'm not a doctor. I would hate to say, especially not on video. But
When I was little, I used to have, like, every year I'd get at least 4.
whoa, is she done?
No,
What's wrong?
you didn't round it.
You don't have to round.
Oh, look how many digits significant digits you need. How many significant digits do you need?
Wait,
4 digits.
so do I have to add a 0?
You gotta add a 0.
I told you you had to round it.
Well, really, you didn't have
It's
to.
not
You could've
rounding.
You
You
could
just
have just
add
written it with the extra 0 on there if you wanted to. Okay? But you got to have 4 digits in the final answer because that's how many significant digits you need. For the same reason we talked about before. In your problem, the number that has the least digits is the one that's 12.25. It has 4 digits. The counting numbers, 2 and 4, or the 1 underneath the 12.25, those don't really matter. Okay? Those are infinitely significant. We ignore those. What? Well, I don't know. I haven't counted them yet. Want to count them? All right. Well, we're going to give you some. I'm going to write out some makeup work here in a minute. Okay? So just be patient. All right. We've got to have an equality statement. So the equality statement needs to have the number, units, and species, number, units, and species, and an equal sign, right? 1, 2, 3, 4, 5, 6, 7. That's 7 for this part. Okay? You got to put your starting amounts over 1 with the units and species. 1, 2, 3. 1, 2, 3. You got to cancel out both of those. 1, 2. You got to put it over 1. You got to add 1, 2, 3, those things, these 3 things, and cancel those. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Where's the 14? Oh, 14. Okay. You're right. Then you got to have your unrounded answer. That's 15. Got to underline. That's 16. Got to have units and species. 17, 18. Arrow is 19. Units or number, units, and species. That's 20, 21, 22. Total 22. With the first one. Okay. How's that? Okay. Well, but it's what you need. All those things you need. Okay. All right. Number, units, species, equal sign, number, units, species. 7 points. Number, unit, species, cancel, cancel. Over 1. Number, unit, species, cancel, cancel. Equals, unrounded answer, underline, units and species, arrow, number, unit, species. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I didn't count the equal sign, did I? 27, 28, 29. I think it's 30. Did I count it right?
I don't think so.
And do it over again?
Yeah.
You can count it for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 points. All right? All right. Balanced chemical equation. Coefficient, species, physical state. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. We don't count the one in the middle here because you can get there in different ways. That's 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51. And since you could have just gone ahead and write it that way, I'm going to count for the arrow and around it. You could have just put a 0 on there and fine. So that's 51 points. 51 points. Okay? So that's a total of how much? 51 and 30 is 81 plus 22. What did you say? 100? 103? Okay, 103. Total for everything.
Mr. Tedder,
Yeah.
I just did that simple addition and it gave me 1.03000 times 10 to the second time.
This one right here?
No, yeah, when I added up all those points,
Uh-huh.
it gave me that. So 51, 30, and 22.
Is your calculator set up in scientific notation?
I don't know.
Okay. If it is, it might be the right answer, just looks funny. Or you might have done the math wrong somehow. Let's see.